Okay, Paul here, and I'm back working on this GE motor that started a video a long time ago, and then we had to send the armature and this plate out to make a new contact ring, which you see in there. Let me see if I can shine the light in there a little better. Okay, they made this new contact ring to replace one that was damaged in there, and it seems to be making good contact on the rotor. But the problems I had were a couple of issues. One, the original one was cracked. I think they might have made new holes in the casting and put in some new ring screws there, Allen screws to center it, and they got it centered good and all. So I don't want to mess with that. The problem is when they screwed it in, it's 180 degrees out. In other words, the wires should be coming out of the other side, not this side. So what I had to do is, because they got to connect to these wires here that I've already prepped and put some shrink wrap on. Those are the ones that had that real gooey liquid tape on them. I cleaned them up. See, they're ready for solder. And what I plan on doing, they go on this side, but because the oil port has to face up, right? And so that's the top of the motor here. So this is the top of the motor. So the oil ports face up and they come off just a little bit to the center. So what I'm going to try to do is I pass them through here. I'm going to try to pass those through, solder them, and then tuck them back in. The concern I had, first I tried to run the wires around the new piece in there. And the problem is these brush contacts ride so close that they were hitting the wire. And of course that's not good, you know, they could wear right through the insulation and short out. So, or yank it and tear it right out of the fixture. So I couldn't run them there. It was too risky. I thought of hot gluing them around that edge to keep them nice and flat, but I don't feel comfortable with that because if the hot glue let go, again, same problem, right? So what I did is instead, I pulled them away and put a wire tie here, which is keeping them flat so that you see there's not a lot of clearance, right? You think that when they designed this, they would have made those brushes, not the guy who reworked it, but the original engineers, when they made the fan, would have made those brushes up higher, closer to the armature, or move the armature away from there more, so that these would not be so close to the wires, because obviously that clearance was an original issue. The other thing is when I tuck these in, I want to make sure that they're nowhere near there. So anyway, I got the wires here. I might have to use additional wire ties. I really don't know how else to do it. I don't feel good gluing them. They need to stay here along the case and come over to this side where they belong. And I separated them by one hole each. As you can see, they're sticking through a hole apart. One's sticking through here, the other one's sticking through here. And so that way, if I pull these through, they're one hole apart. I'll solder them on the other side, right? Not over the hole, but through the hole, solder them, and then just tuck the solder joint back in, and that should tuck it in down through here, away from the drive mechanism. But I got to figure out how to keep these wires along the perimeter all the way to where they're popping through over here. The only other thing I could do, like I said, that I can think of is wire ties, but I don't really want to tie them this close to the armature. I'd really like to get them to stay here, but I might just go ahead and connect it, do a test, make sure everything's going fine, and if it is, I could use some epoxy, which will stick to this, I believe, pretty good. Better than hot glue or anything like that. And epoxy the wires, tack them in place here and along the case, on the inside of this rim here. Just epoxy them in here on both sides coming around. Because I am not taking that centerpiece out. There's no guarantee that if I turn it around and put it back in that the screws will line up. And if they did, there's no guarantee that I'd get it right where the brushes make good contact. They did a good job on that. I'm going to leave it alone. But for a test, this is fine. I don't care if they're floppy around while we're testing it. If it works, then I can come back and epoxy, take it apart and epoxy these in. So it's going to be a two-step process. And again, I'll solder these on the other side, right, where the wires come out the back here. I'll solder them there and leave them out while I do the test, because I don't need to tuck them in. I just need to have them connected so we can check the motor, make sure the motor is going to work. I still don't know the actual condition of this armature. It seems fine, but you know, this is all re-engineering. Everything's being rebuilt and re-engineered on this fan. So we'll see. Even the speed coil with looks like a new component. So we're rebuilding an antique fan basically, not just servicing it. And I think it'll be fine. I think if I epoxy these in there, it'll be fine. And where I got the wire tie, I'll definitely epoxy these too. And you know, I'll scrape the metal a little bit so use black epoxy to make sure it sticks. And the epoxy should hold. Then I can spray shellac over that too once that dries and shellac it in place. But you know, it is on cast metal, so you know, we'll see how that goes. When I epoxy it, I'll video that so we can see, you know, how strong that is. But right now, my only concern is getting it tested. So I did connect the wires with jumpers and turn the armature, and I was checking the resistance, and it was uniform all the way around. So it fluctuated a little, but that could have been me wobbling this, right? This is loose because it's not in the other bearing. So, but it seemed fine. So we'll check that out too. Anyway, that's where I'm at with this. So I'm about to assemble it together, and we'll do a test and see if we can get the motor to spin. And if we can, if the motor spins fine, then I'll disassemble it and we'll look at epoxying this. Thanks for watching. Okay, the fan motor is running. It's making noise, but it's running, and that's a start. On 107 volts, it's 108. It's rated 110. I don't know if the current is good or bad. It's 1.2 amps, almost 1.3 amps, which is 105 watts. Well, the watts really isn't a big deal. The current draw and the voltage is. I'm going to try to get it up, you know, it's running. It doesn't have oilers in it, but that would make the current go up a little bit too. I did oil the, let's bring it up to closer to 110. Right there, 110. And it's drawing 1.2 amps. That's not really bad. So it is running. That mechanism makes noise, but I'm assuming it probably did make a little bit of noise. It's not spinning very fast, but it is spinning. Doesn't have a lot of torque. In fact, no, I can stop it. That's not good. Okay, we'll bring the power down. That only pushed it up to 1.4 amps. I know I couldn't show you that because I had to shut the power down, but when it stopped, it went up to 1.4 amps, which is not bad. I mean, it could be, you know, a lot of antique fans run at 2.5 amps. So it could be that I don't have the case tight. I'm going to go ahead and oil it. Put some oil in here and see if we can get a better response. The wires are okay. Yeah, I got them jumping on to the wires that they're going to solder to eventually. Of course, they're going to be cut, right? And I got it connected at high speed because this is no no speed switch. We're bypassing the switch, so we're on high. This should be spinning. Let me put some oil in here and maybe try tightening some of these screws. I'll tell you what I'm gonna do. I'm gonna put the camera overhead where you can see me working and see what's going on, and we'll go from there. Let me set it up. Okay, so now I'm gonna put a little bit of oil in on the shaft. Okay, and turn that, let it work in there. That sounds a little better. And yeah, I see it coming through here, so that's good. And the front bushing. Let's see if we can get a little oil on that. No, I don't need to. I see it's got plenty of oil there. Okay. Of course, now I'm going to be playing around with 120 volts, so 110 volts. Okay, this moves in and out. Might not have the right number of spaces. You can see it moving in and out there. Let me put a piece of sticky pad, if I can find my sticky pad. There it is. Cut a piece of this. We'll just put this here so you can see it turn. All right, now we'll bring the voltage back up. Okay, I'm at 99, all right, I'm at 110 volts. It's drawing 1.6 watts, not running. It's at 1.4 volts. So it's not the oil that's the problem. It's humming, but it's not wanting to run. Why aren't you running? It's like it's got a phase issue. Current's fine. It's 1.3 amps. It's not overheating or anything, and it's not feeling warm to my hand. Now, it was running a little bit ago, but it don't want to run now. There it goes. Well, almost. Huh. So it needed to be kicked off. It sounds better. It's smoking a little. Let me shut it down. Okay, well, something's getting hot, and I'm imagining what's getting hot is those contacts on the back of the motor. So we got a problem. It could be a shorted stator coil. That's a possibility. If some of the turns in the stator got hot from, you know, all that's been done to it. That's a possibility. Now, the current draw is not bad, so it doesn't look like it's the current from the stator. Let's go ahead and we're going to go ahead and take it apart and see what was smoking, figure out what was hot. And that'll tell us something. The case is cool, so that's a good sign. Normally when a stator is bad, you get a lot of heat there. And I'm just going to disconnect the wires here so we can pull it apart. Some of the smoke could have been oil too. A little bit of smoke came out of there, which let me know it was getting hot. But the current draw wasn't bad, so it didn't look like it was an electrical, like a current-related issue, like power consumption. It wasn't drawing too much power. So it's just, it could be, like I said, some shorted turns in a stator. That is a possibility, and if that's the case, we got an issue. Or it's the new contacts are not conducive to the amount of current that it needs to draw, and I wouldn't know why that would be the case, but we'll have to figure that out too. Okay, so now I get all the screws out. Yeah, let's see if we can take it apart. Okay, here it comes. Okay, it was this side that was getting hot. Yeah. And it's got some wear and tear on here. Coil has a little bit of heat. Not bad. Actually, it isn't bad at all. I mean, there was some pitting here. Well, actually, no, that looks like that was from the manufacturing. Yeah, that's from the manufacturing. That's a joint. It made a black ring around this one. Only on one side, only right here. Can you see that? Let me shine some light on here. Hold on. I'm going to upload this video for the customer so he can see it. This will be just part one. But, I'm sorry. This will be, not part one. This will be later on in the video series, but I'll renumber it accordingly at a later date. But you see how around that, I don't know if you can see that, around that brass, there's a black, see it? And it's mostly on that side, which means it was, see, this side's nice and clean. See? Nice clean. But that side from here all the way around to here, we've got some scuffing from the brushes. So it could have been the brushes that were getting warm. And there's one of the pulleys, okay. See, and they're well greased. Let's take another look at this part. Okay, yeah, we've had some arcing here. See this brush here? Can you see that? Again, I'm gonna have to get the wire right up there. See that brush? It's black and arcing, so it wasn't making very good contact there. And the other one has got a little bit of arcing too. That's what was smoking, was those brushes. So let's find out if we can figure out what to do with those. They are made up of two brushes, one behind the other. There's like a copper reinforced plate behind the brushes. So the brushes are brass. No, it shouldn't be brass, it should be copper too. Hmm. Make sure they're making good contact. This one was arcing here. And I'm sorry I can't get that down. Let's see, maybe I can get closer. I'm going to move the camera so just be aware that I'm trying to get you closer here. Okay, let's see if we can pull that over here and put some light on there. All right, what I'm getting at is see how this one, oh, I guess it is split. I take that back. I was wrong. It is split. But they're joined together so tight that you can't tell there's two there. Oh, there they are. See them? And this one is a little bit spaced. This one is really spaced. And this one's not. Now this one also turns up and down a little bit. That shouldn't make any difference. This one doesn't. It don't move. This one moves. But you see how they slide in and out here. They're supposed to ride. They ride, you know, if that's uneven, that's supposed to be like that's on a spring, right? So it can follow the pulley as it's turning. Same with this one. They seem to be functioning fine. The armature's not hot, but there is some wear on them. See the wear in there? And here. And some old wear back here. Maybe they just need to be cleaned really well. Could be oxidized. Let's put some copper cleaner on them. And kind of rub that in. And let it get that oxidation off. That could be what was burning, was just oxidation. I don't know. They seem okay. And I'll take a little sandpaper and clean them up a little more. Some thin sandpaper here. Now, they seem okay. They don't seem bad. All right, this one here, if you can see that one, see it arced there and here. It arced here really bad. That one's not sliding as freely. Let's see. Yeah, see, that one's sliding really good. This one is not as much. Looks like this got hit by a grinder here accidentally when it's being worked on. Let's just take the armature right out. Set that aside. All right. Let's see if I can clean this off a little bit and maybe make that slide better. You see this really fine paper here. It's not thick at all. It's just almost like emery cork, but a little bit more. And that one sticks. I don't like the way that's moving. And I see it's not going all the way back up. Unless I let it go fast. If I let it go slow, it binds. I'm going to take that one apart, clean it, and see what's involved in cleaning it, and then maybe we'll clean them both. Apparently this little screw holds it together. Oh, it's in a couple pieces. Oh, geez. Okay, there's quite a bit in there. Ah. All right, there we go. That's the contact assembly. Let's clean it up good. See, it's like got some corrosion. You can see where it was rubbing. They're clean them up and let them slide better. I don't want to get it out around. I just want it to get some of that junk off of it. It looks better. Yeah, it's got a wear spot there. See that thing? And I can feel it with my fingernail there. So that's where it was binding. It would come down and get caught on that edge. I'll take a little bit of that out of there. Shouldn't be that big of a deal though. Okay, I think that's better. That's the back side there where, see, it's been one down, but that doesn't matter. That's just the back end. Okay, so this goes in here, connects into that. Somehow or other. Okay, well, the spring holds it apart anyway. Take a little bit off of there, just a little gently get off some of that corrosion. And we go off it in there. That looks better. Okay, that's that. Let's look at the contact here. This is the one that was, see, that's clean copper there, but you see here where it was arcing. Let's go ahead and clean the copper up. Okay. You see what I mean by how they're sandwiched together? They're dual contacts. So they just, I don't know why they would have spaces like that. I guess they just used two pieces of copper. Yeah, they did. And put them together, I guess, to add strength. Probably easier to make thin layers of copper than obviously making a thick layer of copper. Too bad it's not flat all the way. It's got this indent. If I would just turn it around and use the other side. But we'll clean it up a little bit. And we thought it should be there. Copper's pretty soft metal. There we go. That's pretty. All right, let's put this one back where it goes. The big old spring goes in there. It's twisted out of shape. That explains why it was acting up. Right. So that goes in the bowel, and that pushes that against that there. Okay. Let's clean that side out too. Make sure there's no good contact. I mean, it shouldn't make any difference if it's a little bit oxidized, because these are contacts, you know what I mean? We're talking 120 volts at 2 amps. A little bit of oxidation ain't going to stop it. But still, I'll clean it up so make a little bit better contact. And those are brass, so those are fine. All right, now this goes in here, like that. And then that goes up through there. Of course. Okay, let's try it that way then. I'm going to put it with the same bent end down the way it came out. There. And that's going to go up in, no, take that out of there. It's going to go up in there. I hate springs. Not my favorite thing to work with. Okay, we got that part. Now we got to pull this down enough, yeah, to get this back in there. And it goes that way. Okay, and then another piece. It's just a square, it doesn't matter. Feels better. Looks like that got bent there a little bit. It seemed to make it worse. What is your problem? Yeah, this one got hit. You see how it's all scraped up here? It got hit and it got bent a little bit. See, it's not straight up and down, it's got a slight bend to it. And so it's not wanting to ride on that. And it's in that one spot that I'm showing you on that barrel over here. See how that's not straight? It's twisted like, should be like this, but it's like that. And that's making it harder to go through there. If I can straighten that out just a little bit, if I'm really gentle with it. And this brass. Copper, it's copper, no brass. It's better, but it's still binding. And then here. And since I got ground down, there's nothing to grab out there. Oh, almost got it. Better. So I'm going to go a little bit more. There's nothing to grab onto to straighten it out because I think I grounded. They are crooked. Look at how crooked this one is. It's not straight. It's twisted in. So they do get crooked. And again, that shouldn't matter, but that needs to ride on that section there. Oh, contact clean line. Oh, assembly just doesn't feel right. The problem with copper is it's soft metal. It looks so weird. It looks like it's like even this isn't straight. What's that? Let me tighten and see if it straightens it out more. No, it made it worse. The screw's not crooked. The screw's straight, but the better. Okay, it's running again, but it's still not running good. Definitely got more torque than it had. Actually feels a lot better than it did the first time I ran. But it's still not running perfect. I'm going to let it run a while. Maybe it just needs to burn itself in, you know, on those brushes. Right now we're drawing 1.3 amps. 1.2 is jumping, you know, for 1.24, 1.27, 1.29. So about 1.3. That's not bad. For a motor, that's actually pretty good. It's drawing 127 watts. Power factor is 0.9. So it's running okay. It'd be interesting to see if it starts smoking again. The smoking was the contact, not the coil, which is a good thing. The coil was fine. It wasn't even hot. But I'm going to keep an eye on it, let it run for a minute or two and see, you know, how it does. Still making some clicking sounds every now and then. I changed the spaces too. I put some new spaces in there, felt spaces. Somebody had some metal ones in there, I pulled them out. You don't use metal spaces. But I put some felt spaces and got them working. Well, it seems to be okay. Now it's down to 1 point, well, it's still about 1.3 is the worst. I can smell, the electrical smell, which is from the contacts. Starting to smoke a little bit again. Coming still not bad. Anywhere from, it's making more noise. Anywhere from actually it just dipped to 1.7. Now it's back up to 1.3. It's jumping between mostly 1.23 to 1.29. Smoke seems to subside. Let's see. And let me give you another view of this. Disconnect the camera here from the support. Okay, you can see in there where where the smoke's coming out now. Let's see where the contacts are in there spinning. And there's smoke coming out, but we're still not excessively hot. I don't know if that could be oil. It's actually a contact getting hot. I'm going to shut the power down again. I'm going to have to open it back up and find out why that all of a sudden starts smoking. It could be the liquid tape they put on the wires. That stuff is not good for some applications, and it could be that when it gets hot, it starts smoking. You can see part of the ring there. Shine the light in there a little better. Can you see that in that hole in there? Let's see if I can get that to the right place. Yeah. You see the ring in there? Oh yeah, you can see it there. If I turn the motor, you can see how it goes around. Up here you can actually see the ring. If I could get the light to stay in there where you could see it. Yeah. See the ring in there? Looks pretty clean. I'm only seeing one ring. I can't see the other one. But that ring is looking pretty clean, and this seems to be riding fine, this brush. What is strange is the way it goes around. It goes toward the contact. You would think it would turn this way, away from the contacts. That they would drag behind the motor, but they're actually pushed by the motor. Just seems backwards to me. But can't be backwards because it's an AC motor. It'll only go in one direction, I think. I mean, I did have to spin it to get it going. It is a little warm. But again, I don't think it's outrageously warm, and it's not drawing a lot of current. Let me kick it up again. back up to 110. Now, it didn't want to start on its own. I had to spin it. See, right there it should be spinning. And it's not. Let's see if we can get it to spin the other direction. No, it won't spin that way. It'll only spin this way. And once it stops, it doesn't want to spin the second time. And that's so weird. It's a current draw, 1.37. Yeah, when it's not running, the current goes up, but it only goes up to 1.37, which is, 1.4. It's not a lot of current. I don't know. I don't know what the issue is with it. I don't know why it won't kick off on its own. I don't know why I got to spin it to get it going. And then when it's going, I don't know why all of a sudden it starts smoking on those contacts. But again, it's not very warm. I'd say it's around it's probably around 100. That's not really hot. I mean, it may not even be 100. It just feels warm to me because I'm cold. My hands are cold. I could check the temperature, but I know that that's not the issue. I'm going to go ahead and take it apart again. I don't know what else to do but keep fidgeting with it and hope that I can get it working. So this will be my last attempt for today. Okay, it is still got some issues with this thing. But I don't think that's the problem. I mean, it's not moving good. Like that one. It hesitates. So I do need to get that working like this one. And I will. I'll figure out how to line them up so that it slides better. It's sliding much better than it was. But it's still hesitant. And in here, still got a problem with this. You can see here, where it got hot, sparks here. Also, there's a black spot there. I don't know if that was there or not, but regardless, that's irrelevant. There's a spot here, and then there's a spot. Where's the other one? There's that one, and here. So you can see there's one here, and then there's one here. So this one is right near this screw, and this one is right here, and it's even with that black spot there. I don't know how these wires are connecting. It's kind of ironic that there's one here where this wire is, and then there's one over here, and that wire seems to go in that direction. Right? This one definitely goes straight toward that one, or sort of. The wires are here. Now, I don't know if they're rubbing on the shaft. That one lines up with that black mark on the ring. See it there? This one, use my eye to see it. I can't use the lens on the camera. Where's that other black mark? Oh, there. Yeah, this one doesn't line up. That one there doesn't line up. this side. This one here goes from here to here. It's actually, you can hear it? It's like a cavity. It goes from here to here. That one doesn't line up with a wire. The other one does line up with the wire. There it is there. The wire comes in here. There's this black spot here. And the wire is right there. Apologize having to keep moving around, but there's the wire there. And you know, the armature is not supposed to touch those wires, obviously. Actually, it's this dowel here. It's not supposed to touch those wires. And I'm not sure. See, that looks like a spot there. Right there. I'm going to turn the armature. It's hard to turn when it's on. Sorry about that. I don't see any arcs on that, other than that one little spot. And that could be just a fluke, right? I mean, that could just be a colored spot there. There is some, like, discoloration in the brass here. It's like orange. But I don't see any evidence that that's a problem. I don't like the fact that this black spot here, this black spot here, and this wire are all in a row. I don't like that, and it actually is where there is a wire. That doesn't thrill me. Yeah. Let me see if I can get a magnifying glass in there so you can see it a little better as to what I'm seeing. It's hard with the light and everything else. Trying to get the light behind the camera, and yet the camera close enough to show it to you without the reflection of the light. See that pit? It's not just a crater, but see the pit there where it's actually been arcing. And that's where it's smoking, I'm sure. It's right there. Why is that there? This is a brand new ring. Yeah, it arcs right there. It's almost like the wire is burnt through. Is that the end of the wire? Is that what I'm seeing? That looks like the end of the wire. I can't tell. I don't know if that looks like copper. That looks like copper. That looks like the end of the wire is sticking through the ring. Right there. That would definitely arc, and that would explain why it's getting hot if it isn't connected to that ring really well. And that would explain the black spot. But if that is the end of the wire there, sticking through the metal, see it? Right there, just past my fingernail. See it when I move my hand out of the way? That looks like the wire. And it's in line with this wire, and it's in line with the black spot. and you can see the wire in there. Well, can if I move the camera, it's right there. Yeah. Can't get the light and the camera in the same place at the same time. That really sucks. Sorry. There's something under it. Oh, that ain't helping. Yeah. Yeah, as soon as I get over there, I'm moving the light there. Now you can see it. I'm wondering if this wire here is going right, instead of just soldered to the inside of the ring, if it's actually going right through the ring. That's a solid wire. And when you look at it over here, I could keep it facing the same way. You can see it there. That looks like that might be that wire sticking out right there. See it? It is. That's the wire. That's the wire. It's sticking through. Okay. I looked a little closer, and yes, that is the end of the wire, and here's the end of the other top wire over here. And if you look from the back, you can see that there is some solder. Well, there's a solder joint here. See where there's dripped some solder? So apparently they soldered them when they made it. And they used, I think they used copper wire or aluminum wire that's already tinned. So it should be a good connection. And the fact that it's there and here is really weird, but the other one is over here, and it's not near anything, and there's no reason for it to have arced there too, except that maybe the brushes, are rubbing. The beginning of this one is here, or the end of this one, and the end of this one's here. They're almost 180 degrees out, but not quite. But then these are not exactly 180 degrees either. Close though. So I don't know. They're just too close together to be a full out. This one would be here and this one would be here. So what I'm going to do is one more time take this apart and try to get this cleaned. Seems fine though. I don't understand why that would be a problem. That seems to be doing fine. I don't know why it's arcing in those two places. It shouldn't be. It shouldn't be arcing in those two, on those discs. The top one's just got a mark all the way around. It doesn't really have an arc, except here it's clean. And then right about there, it starts with a line that goes around about just past the wire there to about there. But that don't bother me that much, because it shouldn't be there. But this one down here is kind of deep. And this one is kind of suspicious. I really don't want to take this apart. I don't even know if it's glued on there or not. I mean, I'm wondering if this wire had a break in it here, and and it's burning through because it's just a physical contact where the wires broken and the two pieces are getting hot, touching each other. I don't know. I don't know. I don't understand. But that's really weird. So I'm going to upload this video, let the owner see it, and then try to figure out where to go from here. But I am going to try to service this one more time. Right now I don't see any issue with it. It was a little hesitant, but it doesn't seem to be hesitant. I think it's worked itself in. That one's fine. That one's fine. I like the way this one moves better because it is more of a smooth transition. This one's sort of like flop, 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 flop. So yeah, I'm going to try to service this one to make it more like this one. But I don't think that that would do that. And like I said, that is suspicious because it's right over the wire and it's right in line with that burnt spot. That's very suspicious. That makes me wonder if the wire's busted in here. You know, the insulation may be fine, but the wire inside may be cracked. And in which case it would get hot, and then that would arc because that's where all the voltage is going through, right? Rubbing on there. And the other one, I don't know, it could just be, I don't know, I don't understand that. But it's the other brush, when this one's arcing, this is arcing too. You know, the both brushes could be arcing on the opposite sides. But what's strange is it's not arcing on the other one, on the other ring, because the plates connect to both rings. You know, it's not like these are two different rings. The two rings are really just separating the, well, yeah, it would be. It is two different wires. Hmm. You know, that is a weird setup. If you got two rings, so actually this is not one wire and this is the other wire. These connect both rings together, and this connects both rings together. Because this is one piece of metal connecting across both rings, this here, see? It's one piece of metal and it just joins the two rings together, shorts them together. This is exactly the same. It's one piece of metal that just shorts the two rings together. And it's like they have two so that if one bounces while it's bounced, the other one is still joining them together. And if this one bounces, then this one's joining them together. Oh, see, that did stick a little there. So if this is getting stuck and this one's bouncing, that would cause an arc. If that one's stuck like that, like it is now, and this one bounces, it would arc because there's nothing making connection. And that arcing would be a problem. However, that doesn't explain that burn mark in the insulation there. That's just fluky. So I'll make this work. Try it again. If that doesn't do it, then there's an issue somewhere in here. I don't know. I don't know where the issue is. There's no way of telling because you can't measure it while it's running, right? There's no way, right? You got to put the case together, so you can't get at it while it's running. So the only thing I can measure is the coil, the wire impedance going to the rings, and make sure that this is doing its job. And maybe that one is causing a problem. It's possible. So I'm going to eliminate that issue. And then once I know that that's not an issue anymore, if it still does it, then it's not that, and it's got to be something else. It's not the coil. The coil doesn't move. It's just a piece of wire. Wouldn't be the armature, because the armature doesn't really do anything. All the armature does is react to the magnetic field induced by the coil. It's not an electromagnet because these two are shorted together, so the armature is not an electromagnetic armature. It's just weird. It's weird. Anyway, that's where I'm at. Thanks for watching.